Hey everyone, welcome to this MLOps tutorial where you will be mastering the essentials of MLOps. Now the agenda of this video is as follows. So as you proceed in this more than 2 hours of video content, you will learn about what exactly is this MLOps, why MLOps, the key high level idea about the stages of MLOps, and then you will proceed with the hands-on part of working with Git and GitHub for the MLOps project, and you'll also implement the CI/CD pipeline using the GitHub action. So you get to experience the complete MLOps project, which is starting from version management to the deployment. Here for the deployment, we'll be making use of Google Kubernetes engine in order to deploy our machine learning model inside this Kubernetes cluster. So I hope you enjoy it. So watch it till the end and do check out the links provided in the description to access the source code. If you have got any question, please let us know in the comment section and we'll be happy to help. So thanks again and enjoy the session. Now when we talk about inefficiency in any system, these inefficiencies in the system are a result of the web of interconnected incorrect decisions which has accumulated over the period of time. Now when we start thinking about solution for these incorrect decisions, we always seek the quick fix, but in reality this rarely helps. Consider a human body as an example. There's no shortage of quick fixes which are sold to us. Like there's a magic pill that will help you to make you healthy. But what we really require is not a magic pill, but a systematic approach. In the context of MLOps, the pursuit of single solution like having a better data or a specific deep learning framework is actually tempting, but it is also insufficient. A successful approach requires an evidence-based, comprehensive strategy rather than a single fix. So let's go ahead and define what exactly is this MLOps. Now this MLOps is rooted in the concept of continuous improvement, which is inspired by the Japanese principle called Kaizen, which focus on enhancing all the aspects of business activity, including your model accuracy and the broader ecosystem which supports it. So you can say MLOps is a fusion of machine learning and the operation which encompasses the process and the practices for the effective deployment of the machine learning models in the production environment. Now this MLOps emphasizes automation, agility and the collaboration, which is very much similar to DevOps, and most importantly this MLOps also supports continuous integration and the continuous delivery. Now the goal of this MLOps approach is standardizing the deployment and the management of the machine learning model, which emphasizes the operationalization, release, monitoring, performance tracking, reuse, maintenance, as well as managing the machine learning artifacts. Now one common question that you might get is, what is the difference between MLOps and the DevOps? Well, I can confidently say that DevOps is an essential prerequisite for MLOps. Now this DevOps serves as a foundational building block without a substitute. The DevOps, which is a methodology for agile software release and the continuous improvement process, which shares a similarity with a gourmet chef approach whenever a chef is creating a repeatable high quality meals. Now in the context of software, DevOps expert possess a detailed knowledge for building and deploying a software in a consistent manner. Now if you have got a data science team who is looking to transition from data science to MLOps, it's very much challenging because of the lack of DevOps experience. So as a result of this, you might struggle over there in order to get the team up to the speed in implementing the MLOps. So that's where this course has been created to help you build the DevOps foundation for the machine learning project and implement the strategies and the tools that we have got in machine learning domain to implement the best MLOps strategies for your project. A simple way to define this MLOps is that it supports machine learning development just like DevOps support the software development. So we'll be focusing on the MLOps tools and the practices which will help you as well as your organization to achieve the MLOps in an organization by following the industry-wide best practice. In this video, let's talk about the stages of MLOps. Now, when I say MLOps is not just about tracking the local experiment, or MLOps is not just about placing the model behind an API endpoint. Instead, MLOps is all about an automated environment and the processes for continuously delivering machine learning projects to the production environment. Here, in case of MLOps, the MLOps consist of four major components. Now, to start with, we have got data collection and preparation. It is followed by model development and training, machine learning service deployment, and the continuous feedback and monitoring. So let's understand each of them in detail. Let's start with data collection and the data preparation. Now, as you know, data is foundation for machine learning. The machine learning models that we are going to build is dependent on the data. So prior to the model development, the machine learning teams will engage in the data ingestion, data preparation, as well as data exploration. Now, to have an effective way of collection of the data, it is very important that you define the goal or the problem that we need to address and determine the relevant data sources or the features for generating the outcome prediction. Now, once we gather sufficient data for the model, we would go ahead and perform the data preparation, data labeling, as well as we will explore the raw data for model integration. Now, when we say raw data, it basically requires a lot of refinement on this raw data. This would include conversion of the data to the numerical format or a categorical format, depending on the algorithmic requirement, normalizing or scaling the features, encoding of the data, taking care of missing values, spelling errors, null values, and so on. So these are the key things that we often perform when we start working with the raw data. Then we would go ahead and perform the model development and training. Here, in the case of model development training, it starts with extraction of the data from the various sources that we have prepared from the raw data. Then we would go ahead and perform the model training and the validation, followed by the model evaluation and the testing. Now, this is where the ML pipelines would come into picture. Now, when we say ML pipelines, which is also known as machine learning pipelines in the production environment, it has got some relevant features. Some of the important features of the machine learning pipelines would include modularization of the code, tracking all the experiments like code, package dependencies, data, parameters, and the outputs for each and every step in the pipeline so that we can easily reproduce or explain the experiment results. And at this point of time, the ML pipeline will also have the version of all the data and the artifacts that are being used throughout the pipeline. And when we talk about the source code, we'll be storing the source code as well as the configuration file in a version controlled Git repositories. Now, since we are storing the code in the versioned Git repositories, we'll also make use of continuous integration technique to automate the pipeline initiation, test automation, review, as well as the approval process. Now, this is what we'll be focusing on as we progress in our learning journey in this course. We'll be learning about various tools that are available in the market, like working with GitHub, working with MLflow, Jenkins, cloud resources, that is AWS, that's an example that we are going to look at. We'll be learning about Prometheus, Grafana, as well as the containerization platform. And once the machine learning model development is complete, we would go ahead and proceed with the next component, that is machine learning service deployment. Now, when I say service deployment, so once we build the model, we'll have to integrate it with the real world data as well as the business application, and sometimes we'll also be required to create a front end as well. Now, this deploying the entire application or part of these application without disrupting the service is one of the common deployment challenge that we generally have when we are working in big project. Now, in such scenarios, we will make use of the concept like containerization, and we would go ahead and make use of the Docker containers in perform the deployment. So when we talk about this machine learning application pipeline, it will have the API services or the application integration logic. It will have one or more model serving endpoint, and this model will also have the data and the model monitoring services, including the resource monitoring and the alerting services. And finally, we have the continuous feedback and the monitoring stage. Now, at this point of time, we will track the infrastructure, data, model, as well as the application metrics itself. Now, wherever possible, we will have set up the alerts on various situations, like whenever we observe a data drift or a concept drift, which will indicate the potential model underperformance, we will have an alert set. And whenever we observe any model performance issues, then in such scenarios, we will create an automatic alert. And in some scenarios, we will also have some kind of automation which will help us to mitigate those issues. And some other key factors that we'll be focusing on as part of this monitoring system scope would include alerting on model staleness if not deployed recently, anomaly detection, and so on. So as part of your learning journey in this video, we have delved into the comprehensive stages of MLOps, which would highlight the importance of extending the focus beyond the model training. Now, this MLOps is viewed as a holistic approach which comprises of four crucial components, that is data collection and preparation, model development and training, model service deployment, and continuous feedback and monitoring. So this approach not only enhances the technical aspects of the machine learning project, but also ensures their alignment with and contribution to the business objectives. So I'll see you next time. Okay, guys, so thanks again, everyone, for taking your time and joining on this live session on implementing the Git and GitHub for CI/CD pipeline under the topic of MLOps. So, folks, this session is being possible with the help of the Manifold AI Learning. Now, let me start by introducing myself. So, my name is Nachiket Murthy. So, I'm an MLOps architect working in a top consulting firm, and I'll be your instructor for this today's session. So, my day-to-day work would include leading the team of 25 people, and I'm responsible for implementing the end-to-end pipeline of data science, machine learning, and the deep learning projects. Now, my key role would include managing the team of 25 plus people and taking care of the entire pipeline, like the the POC to the productionalization, guys. I worked on various domains like retail, healthcare, banking, and insurance. Some of the impacts that I have made till now is like I've successfully led and delivered multiple data science projects productionalization, starting from POC to the production with overall revenue closer to $100 million. I'm a leader on MLOps approach in my organization. I'm an author of top 10 selling e-learning content on data science and machine learning. I've published various courses through Manifold AI Learning and have trained more than 300,000 learners through self-paced courses. I'm certified in AWS machine learning, AWS DevOps. I'm certified in Kubernetes as an administrator. I'm certified in Microsoft Azure as a solutions architect. So this is about me, and I'm glad that I got an opportunity to share my knowledge through this session, guys. So some of the top courses by me which have published through Manifold AI Learning would include Mastering the Statistics, Practical MLOps on AWS, MLOps Bootcamp, which is the latest one, Mastering Your NLP Journey by Becoming Zero to Hero, Linear Algebra for Machine Learning, AWS Machine Learning Specialty Certification. So these are some of the courses that I have created and delivered through Manifold AI Learning. So here, the topic of this workshop is the Git and GitHub where you will learn to implement the CI/CD pipeline for MLOps. So that's the agenda of this session, guys. Now, to give you a better idea, let me just give you a very simple example as what we are trying to do. See, the idea of this MLOps is implementing the automation for the machine learning projects. Now, to get a clear perspective about the same, so let me just show you a version of a software that I'm actually running. So before the start of the session itself, so what I did was I have logged into my Google Kubernetes and I have created a Kubernetes cluster, and there I have actually published my application. Let me visit the Kubernetes. Okay, so there's a Kubernetes cluster that's running in. Now, what I'm going to do is I'm going to say I'm going to get the service which is actually running. So I've deployed a service which is my machine learning application. Now I can access that service by visiting this URL. Now, if I go over here, it just says that welcome to the LLMOps course with GPT-2 model V1. That means I've got a version 1 of my application that is running in the server. Now, what I will do right now is, so I'll just open up the GitHub repository where I have implemented. Instead of V1, I'll just change it to V2. Now, once I change it to V2, so what I'll do is I'll simply perform the commit to my GitHub repository, and then I'm going to push the changes. Okay, I'm going to push to my main branch. So once I've pushed to my main branch, let me open up the GitHub repository which has this content. So if I go to this GitHub repository, so currently the repository which I'm doing the demonstration is this LLMOps Hugging Face GPT. So if I go over here, it says there is a workflow that is already running. Now if I click on this workflow, it says that some action has been automatically triggered. And if I open the details, so what is happening is, so this is currently performing the activity of build, which means it is performing the activity of packaging my application as the Docker container image. And once the packaging is completed, the next steps that I have mentioned is publish this latest image of Docker and then deploy this image. Okay, deploy this image or deploy this latest version of the application on my Kubernetes cluster. So what it means is whatever the changes that happens on my machine learning application that I have built, so that would be visible on this website. So that's what the overall intention of this workshop. So the overall intention is to enable this kind of automation for our machine learning projects. So most of the cases, what happens is, as a data scientist, you will be working in your notebook environment, which is your personal environment, and it is very difficult to use that approach in a collaborative environment. Now that you know how demand this sector is, it is very important that you as a learner understand how to work in a real-time project where you will be working with multiple collaborators. So to enable you that, in this session, we'll be looking into the two important concepts. One is the concept of working with Git, and the other concept is automating it. So we'll be showing you the high-level steps of automation and implement whatever the learnings that you have done. You can implement it for your personal project as well as your projects that you're working for the client. So that's the main agenda of this session, guys. So I hope you guys are excited. So team, if you're clear with the agenda, so please confirm by typing as all good in the chat window. It will take a while to show you the version 2 of the code because once it has been deployed, so it has to be deployed on a Kubernetes cluster. It will take a while, but I hope you guys are excited. So please confirm by typing as all good or good to start so that we can get started with today's agenda. Okay, so now that you're clear what we are trying to achieve in this 2-day webinar session, so let's look into the agenda of this day one. See, as part of today's session, we'll be looking into the key concepts like what is MLOps, why MLOps, the role of version control system in MLOps, And you'll also learn about what exactly is this version control system, how it works, and as we progress at the end of the session, you will be comfortable in working with Git, which is a famous and a most widely used version control system. And as part of this session, we'll also understand as how to work with Git in a hands-on manner, where you'll be learning the important concepts like setting up your system, like using the various commands in Git, or forming the branching, how to host your GitHub repository in the github.com, and how to perform the pull, push. So all those things that we'll be learning as part of today's session. Now, tomorrow's session will be mostly around using the code that we have built in our repository. Using that code, we will be implementing the CI/CD pipeline. We'll create a Docker container. We'll create a kubeconfig file and we'll deploy it on the Google Kubernetes engine. And we'll also implement the CI/CD pipeline in hands-on manner. So that's the overall agenda, guys, of this session. So we'll take a very simple approach in implementing it. So I'll be writing the code in a hands-on manner. I would be we'll take up a very simple use case so that you get the complete flow, which you can implement it in your projects. Okay, so that's the overall idea, team. So let's get started, everyone. So first thing that I want to ask you is, what is your understanding when we talk about MLOps? So I want you to answer, what do you say or what do you understand when we talk about the terminology MLOps? Now, when we say MLOps, so MLOps is a short for machine learning operation. Now, this MLOps, it refers to the practices and the tools to streamline and automate the end-to-end machine learning lifecycle. And that's what the MLOps is all about. So when we say MLOps, it basically combines the principles from DevOps with the machine learning workflow. The reason that we want to integrate it because we can bridge the gap between the data science and the operations as well. Now this MLOps, it encourages collaboration among the data scientists, engineers, that is machine learning engineers, software engineers, as well as the operation team. So by encouraging the collaboration, we'll be able to ensure that there will be a smooth transition from development system to the deployment into the production environment. And when we talk about this MLOps, so one important practice that we generally observe is we will make use of the version control practice. So we will be applying the version control practice for the machine learning models, data sets, as well as the code so that we can track the code changes and facilitate the reproducibility. And this MLOps suggests the usage of automated pipeline where we'll be implementing the pipeline for model training, model testing, deployment, and even monitoring as well to enhance the efficiency and reduce the manual errors. And this MLOps also suggests to implement the CI/CD, which means it encourages to adapt the continuous integration and the continuous deployment principles so that we can automate the testing as well as the deployment of the machine learning models. Now, this in turn promotes the faster and the more reliable model updates. Let's say you've got a system where you're running the model version V1. Now you want to update your model V1 to the latest version, let's say V2. Then in such scenarios, with the help of these CI/CD principles, we can automate this process of updating your application, which is pointing to V1 to V2 in a reliable manner. And the MLOps also suggests for effective monitoring and logging. So when it comes to logging, so it always tracks the various metrics that is involved in the machine learning. So it could be the data features, or it could be the model performance metric. It could be anomalies in the model behavior or from the data set, so that we can ensure the model that we have got in the production environment is effective in terms of real world scenarios. And MLOps recommends scalability concerns. It actually MLOps recommends scalability of the models, or the scalable, like having an environment which can be scalable, which means this MLOps helps us to address the scalability concerns by designing the system which can handle the deployment and the scaling of the machine learning models in the production environment. And it also recommends to have a best security measures in place which will ensure that the model that we are using in the application that we are building, so it always ensure that it is in compliant and the data protection regulations are actually met throughout the entire machine learning lifecycle. And lastly, the MLOps suggests to have a feedback loop so that we can have a continuous way to get the feedback and improve the machine learning models based on the real world performance and the user feedback. So that's the overall way in which we can describe the MLOps. Here we are combining the machine learning and the DevOps side in the machine learning project. Now that you have understood what exactly is this MLOps, why do we require this MLOps? Well, the reason that I want to use this MLOps approach in any machine learning project, because one, and the most important factor, that is we'll be able to have an efficient workflow. So we'll have an efficient workflow so that even with various teams working on a single project, so there will be an effective way when it comes to execution. With the MLOps, we get to enjoy the other benefits like accelerated model deployment, reproducibility, improved collaboration, and other features like enhanced scalability, continuous integration and deployment, monitoring and maintenance, and the resource optimization. So these are the key benefits that we get to enjoy by implementing the MLOps practices in the machine learning projects. Now, here, as you have learned about the importance of MLOps, okay, now let's look into the next concept that we have got as part of today's session, that is version control system. So let's understand what exactly is this version control system. Now, when we say version control system, it's a, sometimes people also call it as VCS. So version control system is a software tool that will help us to track and manage the changes to the source code as well as the other files in a collaborative development environment. Now, why this is important? Well, the reason this is important because when you think about working in a big project, it can be based on machine learning, deep learning, or it can be based on anything. So in all those scenarios, you'll not be the only person who will be working in that project. So you'll be working in a collaborative environment where the source code is used by various teams and various people. So this version control system helps us to track and manage those changes to the source code and the other files in such collaborative development environment. So with the help of this version control system, we get to enjoy a systematic way to record the various versions of a file or set of files over the period of time. So as a result of this, multiple people can contribute to my project in a concurrent fashion. That means multiple people can work on that project at the same time. One of the main goal of having this version control system is to manage the changes, facilitate the collaboration, and maintain the history of modifications to the code or the other file. So that's the main reason that we want to use this version control system in MLOps project. Now, when we talk about version control system, there are actually two types of version control system we have got. One is centralized version control system, and the other one is what we call it as distributed version control system. Now, when we say centralized version control system, so in the case of this centralized version control system, there will be a centralized repository. Okay, there will be a centralized repository. Now, on this centralized repository, the entire version history of the project will be stored. Now, depending on the requirement, So we call it as a client. Client is nothing but the developers who will be working on that project file. So these clients, they would generally interact with that central server, and they will check out the latest code. They will make some changes and they will commit those changes back into the central repository. Okay, now in such scenarios, the history, version information, everything will be maintained in a central place. So that's the idea of this centralized version control system. Okay, it's a centralized version control system. Now, one of the common example for this centralized version control system is SVN, which is the subversion. Now, apart from this centralized version control system, we also have another type of version control system that's called as distributed version control system. And when I say distributed version control system, this is a special type of version control system. Here, what would be using is, okay, so what we'll be using is here in this case, okay, so each developer will have a local copy of this entire repository, which means here if I have two people who are working in my project, okay, if I have two people who is working in my project, both of them will have the entire copy of my entire repository. Now, the best part is both of these developers, they can work independently. They can make the commits to their local repository so that they don't have to be dependent on the server connection every time. And whenever there is any changes that happens between the repositories, the developers can actually perform the activities like pull and push so that they can synchronize their code changes with the other people code changes. Okay, that is how we get to work with this distributed version control system. Some of the common examples of this distributed version control system would include Git and Mercurial. Now that you have understood the two types of version control system, that is centralized version control system and the distributed version control system, let's look into the key difference between them. So when we talk about the key difference between them, so in case of Git, which is a distributed version control system, here in this case, okay, each developer will have a full copy. Okay, each developer will have a full copy of the repository, and this supports non-linear development workflow, which is quite common when you think about working in a large project. And this is better suited for distributed and the collaborative development. Now, apart from that, we also have SVN. So in case of SVN, we have understood that it's a centralized version control system. So here in this case, the developers, when they are working, they'll be interacting with the central repository. Okay, now one of the limitation that they will have in the case of the centralized version control system is the branching and merging. So this branching and merging is not available in the case of centralized version control system, and this requires constant connection to the central server for most of the operation. So that's the overall difference between the Git and SVN. Now, in our learning journey, as I've mentioned, we'll be working with Git repository. So let us understand what exactly is this Git. Now, when I say Git, so Git, as you have learned already, it comes under the distributed version control system, also known as DVCS. So this Git is a widely used software. It's actually widely used in software development when it comes to tracking the changes in the source code. And this was created by a person called Linus Torvalds in the year of 2005. And from then it started, it's actually one of the most popular version control system that we have got in the market. Now, here we can say that this Git has actually become a standard version control system. It has actually become a standard version control system for many open source and the private project. The reason because This has helped in fostering the collaboration and enabling the efficient development workflows. So let's understand in detail about why do we require this in the machine learning projects. So let's understand the same, guys. So here, when we talk about Git in machine learning projects, so first and foremost, we'll be using it for version control of the code. So when we start writing any machine learning application, okay, or when we create any code, we'll be creating the code in the format of, let's say, Python scripts, or we might have some configuration file. Now we want to track the changes to those files. So we'll be using for version control of the source code. So based on a requirement, the developers will initialize such repository. Even you'll be learning in your learning journey in our workshop. So how we like they'll be initializing their Git repository for the project, and then they will start committing those code changes to the repository. So by committing the code changes to the repository, this would enable fostering the code, like the fostering the collaboration between various team members, and various team members, they can make use of the same base code and this can start working on the different feature. Now this can be possible with the help of branching. The various developers will perform the pull request where they will extract the latest version of the code from the repository, and they will create their new branch which will be an enhancement or which can be a change from the original data or the original code that we have got. And from the machine learning perspective, so this is also quite common. Let's say you have got 10 people who is working in a project and you've got a resource, let's say a junior resource, and you want that person to perform some hyperparameter tuning. He would go ahead and create a pull request, and in his local system he would perform the hyperparameter tuning, and he will create his own branch if there are any code changes that he wants to test out, and he would commit the same to the repository. If that is approved, he can merge it to the main branch. And not only the code, which is important from the machine learning perspective in a machine learning project, even data plays a key role in a machine learning project. So this Git supports large file storage. So for versioning the large data set, so we can actually make use of Git LFS, which is an extension of Git, which can handle the large files in an efficient manner. And if you're working in a cloud environment, you can also make use of such cloud storage as well. And this Git also supports the data versioning. You can also track those changes as well as part of your requirement. And here, apart from that, you can also use the Git in tracking the model artifacts, that is the model files. You can use this Git for experiment tracking, continuous integration. So these are the various use cases or the various ways in which we'll be implementing the Git in the machine learning projects. Okay, guys. Now I can see few questions over here in the chat window. So one question that I see from Asik is, so what is the best practice for machine learning project? Is it DBCS or CVS? So the best practice is DBCS. Okay, the reason because you like if we depend on the centralized repository, if for some reason if the central repository is unavailable, this would keep my entire project on hold. So we don't want to do that. So by making use of the DBCS, so we actually get to enjoy the benefit of we get to enjoy the benefit of having the same code everywhere, even if my remote repository is not available. So we can still get the code from the other people who is working in that project. Okay, so let's proceed ahead, folks. So now that you are clear about the theoretical aspects about what exactly is this version control system and how it works and its importance from the machine learning standpoint, now let's proceed ahead in the hands-on and let's go ahead and get our system ready. We'll get our understanding as how it works, like we'll initialize the repository. So as I mentioned, today's agenda is about focusing on working with this Git. So we'll initialize our repository. we'll commit the source code, we'll perform the branching, and we'll also make use of repository hosting. So we'll make use of github.com and we'll host our repository over there. Okay, that's what we'll be doing, guys. First, let's start with the first task that we have got, that is getting our system ready. So in order to get this system ready, okay, in order to get the system ready, the first thing that we need to do is we need to install the Git in our system. So just search for Git download. So this will take you to the page of gitsem.com/download/win. Okay, depending on your operating system, you can actually choose it, guys. So I'll share this link to you, everyone. Okay, so let me share it on the LinkedIn as well and the chat that I have got. Okay, so first thing that you need to do is you need to download the Git in your local system. So follow the instruction, which is a simple instruction. Just follow the instruction, and in that, just perform the download the Git. Just perform the normal steps that you would do, guys, like when it comes to installation. So just download it and perform the installation. And once the installation is complete, so when you're working in the Windows system, so this would actually install this would actually create something called as git bash. Okay, it would create something called as git bash. I'll show you some screenshot how it would look like when you're installing it. Okay, so once you download it, guys, okay, so depending on your operating system, just go ahead and download it. So while following the instruction, okay, so just follow along. I'll share this link as well for your additional information uh, to see as like the steps to install the Git. So just go ahead and select the destination screen, click on next, next, next. You don't need to do anything, just follow the instructions and complete the installation. Okay, just complete the installation. Now, once the installation of this is complete, okay, once the installation is complete, the next thing that you need to do is you have to validate your installation. So to validate your installation, so what you have to do is you have to run this git bash in your local system. Okay, you have to open the git bash in your local system, and once you open the git bash there, you need to run the command of git space version, and that is how you'll be able to validate whether the git has been installed or not. Now in case if you're working on Mac OS, so what you can do is you can just run the command of git space version in your terminal, and you should be able to see a version over there. So this will confirm that the Git has been installed in your local system. See, git space version. So the important system setup is you have to download the installer, and once you do the installation, run the command of git space version, and this will install the Git in your local system. Now we have installed the Git. Now we have the system setup in place in order to get started. Now, when we talk about Git, okay, there are some fundamental things that you need to understand. So first and foremost, if I want to get started with the Git, okay, if I want to get started with the Git, first I need to initialize my repository. Okay, first I'll have to initialize my repository. But even before that, okay, even before that, we have to do some setup in our command line interface. So we have validated that Git version and we have ensured that this is working, the Git is working. Now, apart from that, you also have to do some setup, which we call it as Git configuration. So let's go ahead and do that configuration. For the benefit of today's session, I'll just create the source code. Okay, let me start mentioning the command and you can access it at a later point. So the first command that you need to run is obviously git version. Okay, so by running this command of git version, you should be able to confirm what is the version of the Git that is running. Then we would go ahead and perform the configuration. So the Git configuration are basically the settings that would allow us to customize how does this Git would work. Now we'll perform this Git configuration. Now this Git configuration, it consists of variables and their respective values, and it will be stored in some set of files, guys. So to work with Git, this configuration is mandatory. So if you want to display the configurations, you can run the command of git config -- global -- list. So this would help me to display the configurations that I've got in my system. So if I mention that command and press the enter key, in my case, I have already set some variables. I've set a variable of user email, and I've set a variable of my username and some init default branch as well. Now, if you're running it for the first time, you might get an error as well that says that there are no configuration exist. That is completely fine. So as part of our hands-on, it is important that you run these commands so that you'll not get any errors while working. So first is git config global, and we will set the username. So I'll give an example, user.name, and mention your username which you want to use it whenever you are performing the command. In my case, I'll just mention my name, that is Nachiket. It is up to you as how you want to use it. And apart from that, the another important one that I would recommend is setting up the user email by mentioning it as user.email and mentioning your email address. Okay, then another important thing. This is very much important if you're working in some system where the default branch is not main. I would always recommend it so that that will be a easier one. You don't have to worry about it when you are performing the commit and working with various cloud platforms. So git config -- global init dot default branch main. So what it means is, by default, whatever the branch that you're going to create, it will be a main branch. So you just mention these commands. Okay, once you mention this command, paste it, so it will be done. So you can also validate it by git config global -- list. So you'll be able to validate that as well. Okay guys, so now that the setup is done, okay, so this what we have done is we have just performed the setup of our command line interface. Okay, now with this setup in place, now what we can do is we can quickly go ahead and get started with the repository. Now, if I want to start tracking the changes, okay, if I want to start tracking the changes in my local repository, then we will make use of the command that is called as git init. By mentioning the command of this git init, we can actually get started and start tracking the changes in my repository. Currently, I have created a folder called MLOps webinar. Okay, now this is not tracked by Git. Now, any changes that I do over here on my readme.md file, it will not be tracked by my version control system because I've not told them. Now, if I want this files to be tracked, then the command is git init. So I can say git init in order to track the changes. So I'll do one thing. I'll go to that folder where I have just created. Okay. So if I go to the folder of MLOps or webinar, okay, which is my today's which is the folder that I've just created. So here in this folder, there's a file that's called as readme.md file. Now, if I open up that folder as well, this is my folder. So in my case, yeah, if I go inside this folder, there's only a single file which says as readme.md file. Now, in order to start tracking the changes for this file, we just can run the command that's called as git init. Now, when I say git init, so all the files that are part of this folder, we can start tracking it. So when I say git init, it says it has initialized the empty repository. Now, apart from that, if I enable the hidden files or the hidden folders, you can see that there's a new folder that has been created that is called as .git. So this .git folder indicates that This is basically the folder which is being tracked by this Git version control system. And if I go inside this .git, you get to see various elements. So you have something called as config, description, head. So all those things, it will be created by default. So git init is the command that we use it to give the command to the Git saying that this is the folder that I want to start tracking. Now, once I start tracking this, if I want to check the status of my repository, I can run the command of git status. Now here it says I'm currently on the main branch. Okay, there are no commits yet, and there are files which are untracked. Okay, there are files which are untracked. So which means there is a file in my current directory, and this file is untracked, which means it is not yet started. The tracking of this file is not yet started. So there's a key concept that you need to understand right now. So let me just explain you with an example. So here, when you are working, okay, so when you are working, so let me just take an example, okay, to help you understand this concept of repository. So what we did is, so we started our folder, and I've mentioned the command of git init. And as a result of mentioning this command of git init, there is a hidden folder got created, that is .git, which meant that this is a local repository. And this place, okay, where I have my files present, where I have this currently only one file, that is readme.md file present, this place is generally called as the working directory. So it is called as a working directory. So if I want to explain it, so think of my folder as my as the project directory itself, which is my folder itself, and inside it, basically we'll be having a working directory under local repository. So what I did was, by making use of the command of this git init, so I have initialized my local repository. Now, whatever the file that I have right now, so currently the file that I have is a readme.md file. This readme.md file is present in my working directory, and it has not started tracking it. Okay, it has not started tracking it. The reason, because it can only start tracking it once it is part of this local repository. And that is what the message says right here. It says it is untracked file. So there is an untracked file which is in my working directory, and it is not being tracked. It can only track once it is part of this local repository. So is it clear now, guys? Is it clear? So what's happening in the back end? So why we see that message? Okay, thank you Dheeraj, thank you Ramesh, thank you Rakshit. Okay, thank you Lakshmi, thank you Samiksha. Perfect. Thank you so much guys for confirming. So you have now understood what is that message. Now what is working directory? Working directory is nothing but it contains a set of file which represents the version of the project. Now apart from this working directory, while working with Git, we'll also be working with another concept that's called as staging area. So the staging area is basically, okay, is basically a draft space. It is basically a draft space. It is basically a draft space, and then from the staging area, we'll be performing or moving those changes inside my local repository. So here, in order to move into my repository, we call the term called commit. Okay, so basically, when I have created the file, in my case readme.md file, which is currently an untracked file. Now, by making use of the command of git add, we can use this command and move this file from the working directory to the staging area. Now, in order to start tracking the file changes for this particular file, we will make use of the command git commit so that we can start tracking the changes to the file that we have created. So that's the overall flow that we follow while working with the Git repository. So in my case, instead of f1.py, I have readme.md file. Or let's do one thing. Let me create one more file as well. I'll just say f1.py, and inside this, I'll say print hello world v1. So it will become much more sense to you. Now I have a code that's called as hello world v1, which is my Python file f1.py, and I have this file present. Now, if I run the command of git status, it says that there should be two files which are untracked, readme.md and f1.py. Now to move these files from my coding area, that is working directory, to the staging area, then in order to do that, okay, we make use of the command of git add. It says, it also mentions the hint as well. It says git add. So I can say git add followed by the file name. So I can say f1.py, and I'll also want to move readme as well, readme.md. So I'm moving both the files, that is f1.py and the readme.md file, into my staging area. And if I press the enter key, so what it has done is it has moved the file which is part of my working directory to the staging area. So that's what I have done right now. Okay, now once the file has moved to the staging area, okay, now if I want to save that file, that is save it as a version, then in such scenarios I can use the command of git commit. So I can now open up my CLI and I'll say git commit -m. -m is basically the indicator that where we can mention the message. I'll say git commit -m, and I can mention the message, let's say v1 of code. And if I press the enter key, so what it has done is it has performed the commit. And there is an ID that has appeared, which is 615E53A. This is basically the commit ID. So the workflow that we follow while working in a Git based repository is, first we'll have a set of files which will be an untracked file. We will make use of the command of git add to move the files from the working directory to the staging area. And once it is moved to the staging area, we can make use of the command of git commit to perform the commit to my local repository. So that's the flow of working with this Git based repository. Okay, so to recap, the commands that I've mentioned is here git init, then git add and followed by the file name. Okay, you can also go ahead and experiment it at your end as well, and git commit -m and mention the code, or mention the message that you want to add. So that's how you can go ahead and like perform our work with the same guys. Okay, I've mentioned all the commands into the source code page as well. You can also refer those commands and execute it from there. Okay, so any questions guys? Are you clear till now? Okay, Rakshit says yes, Dheeraj says yes, Prakash says yes, Sangeeta says yes, Ramya says yes. Okay, Jyotsna says yes. Okay, Asik says yes. Perfect. Thank you so much, guys. So now what we have seen is we have learned an important concept in Git, that is how to track the source code changes. Now the best part is, okay, now once this is done, if I say git status, it says there's only one file is there, that is some DS store, which is a default one. Now apart from that, you do not see that file. Okay, apart from that, you do not see any other file. Now what I'll do is I'll show you one more thing. Now I'll come back to my f1.py and I'll change the version to v2. So that means my previous version code, which was v1 earlier, I'm now changing it to v2. Now once I change this to the v2, which is the version 2 of the code, now if I simply go ahead and run the command of git status, it says that the changes not staged for commit. That means there are some changes that has happened on the file f1.py and it is not staged for commit. Okay, so that means it is now tracking the changes for the file that we have got. So not only it's tracking this f1.py, since there were some changes that I did on the readme.md as well, so we are able to see that okay, there are some changes that has occurred on both the files, and it is and we can see that these changes are visible. I mean, these changes are not committed, that is what it says. Okay, now what I can do is, so I can now go ahead and move these files to my staging area. So last time I made use of the command of git add and mention the file name, right? Now apart from that, I can also say git add dot. So dot is going to consider my entire folder. So whatever the files that I've got in that folder, so that will be added. Okay, that will be moved to my staging area. I'll say git add dot. So which means this has moved my files that I have got into my staging area. Now when I say git status, it says that these are the files that are ready to be committed. Now I'll say git commit -m. I'll just say v2. That's the message that I want to keep, and I'll press the enter key. So this has performed the commit. Now once that is done, if I say git log, so git log is going to display all the logs. So here it basically displays what are the commits that have happened. So this is my first commit, and this is the commit ID. This is the second commit, and this is the commit ID. So in this way, we can track the code changes of the repository or the folder that we are working. So by tracking these code changes, we can actually check who has performed what change, and we can go back to that required version of the code if something is not working. So that's a very high level idea of working with Git. All right, guys. So now we'll do one thing. We'll take a short break of 5 minutes. And once we are back from the break, we'll look into the other concepts like branching. And we'll also look into the concept of working with the hosting as well. Like how do we host these repositories and how do we connect our local system to the GitHub environment that we have got. So let's meet after 5 minutes, guys. Let's make it 7 minutes. I see multiple messages saying it has more than 5 minutes. Okay, let's make it 7 minutes. I'll see you after 7 minutes then. Cool. I see confirmations from most of you. Thank you, guys. So let's proceed ahead. So what we have seen is we have looked into a basic idea of how does the commit would work and the way in which it would work. Okay, like first we'll be working in the working directory. To move the file from the working directory to the staging area, we'll make use of the command of git add, and then we'll use the command of git commit to perform the commit. Okay, that's what we generally do while working. Now whenever we are working, okay, we can actually look into the commit history by running the command of git logs. So by running the command of git logs, we were able to look into the various commits that we have performed. Now here we have something called as head, and under the head, like for this head, this is currently pointing to the main branch, which means head is basically a pointer. Okay, head is basically a pointer. It says that where exactly the code that I'm pointing to. Okay, so that's what we have got this head. It is basically a pointer. Now when working in a project, so you'll not be just working with a single commit that you have got. So what you will do is you will be working with multiple versions of the same file. So in such scenarios, we will make use of branching. Okay, in such scenarios we would be making use of branching. So let us understand about what exactly that we mention it as branching. Okay, so let me show you the same thing. Yeah, so here what exactly is this branching? Branching are basically the movable pointers to the commit. Okay, they are basically the movable pointers to the commit. So when do we use this branching, or what is the essence of branch? Well, these branches are the ones that would help us to work in a collaborative environment. So depending on our requirement, we can we can create an independent line of development, and we can use it as a way where you would work, or where you would think it as a new working directory itself. Okay, so let's assume that, to give you a very simple example, let's say you've got a website that is running, and in your website there are various components of this website. Let's say there is a website which has got the cart functionality, and there is a front end. Okay, so like this, your website is made up of various components. Let's say you have two developers that are working. One is going to work on this cart functionality, and the other one is going to work on the front end. So for these two people to work together, so what they can do is, maybe this front end person who is working on the front end, like the developer front end who's taking care of the front end part, so they can actually create a branch called development branch, and they can go ahead and start working and creation of the new version for the front end. And similarly, so let's say I've got the cart functionality, I can have one more developer team, they'll be creating their dev2 branch, and they can independently work on their branch as well. So branching will help us to work on the same set of code in a concurrent manner. Okay, so that's the overall idea, guys. Now when it comes to branching in Git, so we make use of some common commands. So let me just type those for your reference. So some of the common commands that I will be using when we talk about branching is, we'll say git branch. So this is a command which will tell me to which branch that I'm working with. Okay, so like to which branch that I'm working with. Now if I want to create any branch, let's say I'll say git branch dev. So this will actually create a development branch. I'll show you with an example. So first, if I say git branch, it says that there's one branch that present, that is main branch, and there's a asterisk symbol next to it, which means that this is the current branch that I'm in. Now when we say git branch dev, what it means is it has created a new branch that is called as dev. Now after that, if I say git branch, it will tell me that there are two branches now exist. One is a development branch and the other one is a main branch. So I now have two branches present. Now when I say git log, so here it says that my head is currently pointing to the main branch. Okay, my head is currently pointing to the main branch. That is what it says right here. Now, after I have created a branch, if I want to switch to my development branch, that is the branch that I have created, I can run the command of git switch dev. So what it has done is, this will switch my branch to the development. Now when I say git log, this time after switching my branch to the development branch, my head is pointing to the development. And I have the main branch, which is the other branch that I've got. That means whatever the source code changes that I will do, it will be updated on this development branch and not on the main branch. So to test this, I'll do one thing. I'm now in the development branch, right? So I'll come over here and I'll modify the source code as v3. Now once that is done, there's a source code change in my development branch. I'll say git add dot git commit -m, and I'll say v3. I've updated the changes. Now when I say git log, so you can observe that my head is pointing towards the latest commit, and this is basically in my development branch. That means my development branch is one step further from my current branch, that is my main branch, because this is now referring to the v3. Now the question is, what would happen if I switch back to my main branch? That means what would happen if I switch back to my main branch? So if I want to switch back to my main branch, I can say git switch main. Now when I say git switch main, So this will switch back to my main branch. That means this header over here, this will now point to the main branch. So git log, it says that, see, my header is pointing to the main branch. Now if you look into the source code, before it was v3, right? In my development branch, it has been switched to the v2. So that's the overall idea that we have got when it comes to branching. Okay, that's the overall idea when it comes to branching. So you have seen how to create a branch, how to switch the branch, and uh, and how to switch back to the required branch. Okay, so let me mention the commands. So you have created a branch. After you have created the branch, we have switched the branch. Then update the source code. Then I'll say git commit, git add dot, git commit hyphen m. So this is basically v3. Then after that, so you have made use of the command. I think after git commit, I think, yeah, git status, then you have switched back to the main branch. Okay, so these are the commands that have executed till now. Now what I'll do is, my main branch is pointing to the v2, but my development branch is pointing to the, like, my development branch is pointing to the v3. Now in such scenarios, what we can do is we can also perform the merging as well. Now if I want to perform the merging, okay, the way that I can perform the merging is I can say git merge and mention the branch that I want to merge with. I'll say git merge dev. So this will merge the commits. So when I say git merge dev, now this has performed the merging. Now if I now go back to my file1.py, we can see that the code has been merged to the v3. So this is called as the fast forward merging. Okay, this is called as the fast forward merging. In the case of this fast forward merging, so what happens is you will update the source code to the latest version of the code. And this can be done only when the child one that you have got, it shares the same parent. Okay, when it has the same parent as the existing main branch, then only we can performing the merging. So this is a common way in which the merge can be performed. So all the changes that we have been playing around right now, so all these changes are basically part of my local repository. Now the question is, how can I work with the source code which is part of my remote repository, or how can I share this source code, guys? So now if I want to share the source code, okay, if I want to share the source code, I have to host it in an environment. Now that is what we call it as the Git repository hosting. Now to host such Git repository, there are various services that are available out there. So we have got github.com. So the github.com that you see right here, this is one of the service that is available for me so that I can host my Git based repository. Now apart from this github.com, there are other services as well. To name a few, we have got Bitbucket. That's another service where I can host my Git repository, or there is something called as Code Commit, which is an AWS based repository. So like this, there are various platforms that are available so that I can host it in that website and I can share it with them. So this github.com is a place where people are storing the file. Now in my case, I've got a GitHub account and I'm saving the file and I'm able to share those files with you. So this github.com, it's a place where you will be storing such files. So that's the idea of this hosting services that we have got. Now, in order to work with it, so in our learning journey, I'll be making use of this GitHub itself. Okay, so here, create your account by visiting github.com. And once you create the account, what you can do is whatever the source code that you have got in your local system, you can host that source code in the github.com, like in this example. So let's see how we can create a repository over here in the github.com. So what I'll do is here I'll click on this create new option and I'll select as new repository. Now we'll start by specifying the repository name. I'll mention as MLOps webinar Feb 3. Okay, so this is how I would specify the repository name. Now, once I mention my repository name, I'll say create repository. So this has created the repository in this github.com. Now, in order to be able to communicate with this repository in the github.com with my details, okay, what you need to do is you need to have an authentication method with you. So go to the settings of this GitHub. So expand your ID and select the option of settings. Now in the settings page, come over down and select the option of developer settings. Now here you need to generate the personal access token. I'll show you in the session itself. Okay, I'll click on tokens. So generate a new token. Okay, you can select the second one and you have to authenticate yourself. In my case, let me just do that. So here I'll just show you an example. You just have to mention some note over here. I'll say test. Okay, you have to set some expiration. I'll just say 7 days for now and go ahead and enable all the permission. Okay, go ahead and enable all the permission. Now once you enable all the permission, it would actually show you the user ID and password for you. So generate a token. So this will actually generate the password. Now remember, you have to copy this password and keep it with you. You should not share it. Okay. So, and once you close this window, you'll not be able to see it again. So that's one thing that you need to remember, guys. Okay. So I'll be deleting it in the session itself and I'll not be using it. But this is how you would create a new access token. Once you create the access token, so what you should be doing is to get started. So first we need to mention the repository URL to connect to our local system. So by opening our command prompt, we'll say git remote add origin and we will mention the URL, which is basically our repository name, that is this. Okay, in this way we will be able to add the remote. Okay, we'll be able to add a remote repository and I'm mentioning the name as origin. Now once that is done, okay, if I want to push my changes from my local system to this remote repository, then I simply have to say git push origin main. So I want to push to my origin, which is my this link from the main branch. So now it has been pushed. Okay, so what it says is it has been pushed, the code has been pushed. Now if I come over here and if I refresh this page, I'll be able to see it. Now in case if you're running this command for the first time, it will ask you for user ID and password. For the username, you have to mention your user ID. Okay, and for the password, you have to mention the personal access token that you have generated. Okay, so that's the overall way in which you will be able to sync your local system to the remote repository. So what we have just done is we have actually went ahead and created a remote repository. And once we created the remote repository, so we pushed our local code into this remote repository. So that's how we can work with these remote repositories. Now, once the remote repository has been created, let's say if I want to fetch or if I want to get someone else repositories, then what I can do is I can run the command of git clone and perform the activity of cloning. Okay, so that's how you would actually work with the git repositories, guys. So what we have learned as part of our learning journey in this today's session is we have understood the basics of Git and how to host our Git-based repositories in a hosting service, that is github.com. And we have looked into the important concepts like branching, concept of working directory, and pushing the source code to the remote repository. Now, as part of our tomorrow session, what we'll be doing is we'll choose a simple machine learning application. I'll choose the code which I have already implemented in our previous learning journey for our YouTube channel. I'll use that code and we'll implement the CI/CD pipeline for that machine learning model that I've created. Okay, now there were few learners asking about how I can learn more. Well, some of the concepts, if you want to learn more in depth, okay, I would recommend you to check out the course of MLOps Bootcamp, which is one of the best sellers that we have got right now. So you can check out these courses. These are at the like a lowest price right now. So I would recommend you to check out these courses and join over there, guys. And I hope to see you on the class. So all these courses are more than 30 plus hours of learning journey. And these are the best sellers in the Udemy platform. So it has been referred by more than 30,000 learners throughout the globe as part of their learning journey. And I want you to get the most of these courses, guys. So it has been a pleasure to interact with each and every one of you on this session. I hope to see you on the next session as well. Get it? Okay. So I've shared you the link, guys. So what you can do is just open that link. Okay, once you open that link, you'll be redirected to a page of webinar learning material. Click on access now for free, and under the day one, Git and GitHub. So this is where you have the MLOps workshop. So you have the video, the session's recording, which was conducted in the last session, the code that I have typed in the last session, and along with that, the slides as well, the slides that I've used in the webinar. Okay, you can get the access over here from the portal. So let's get started with today's agenda. See, what we did in the last session was, in the last session, so we actually went through the basics. So we have understood what is MLOps, why do we require the MLOps, and we have looked into the concepts of the version control system, and we have understood about what exactly is this version control system and the concepts around the Git, and we have set up our account, that is Git account, that is we have set up our local system with Git so that we can track the version. We looked into the basic commands of working with local repository, and then what we did was we also looked into the concept of branching, how to create the branch, how to perform the changes, and so on. And then we have hosted our local repository on the GitHub, which is a remote repository. And we have seen the basic commands of pulling and pushing. So that's the important commands that we have seen till now in the learning journey. Now, as we progress in today's session, so what we'll be doing is we'll be performing the entire CI/CD thing in a hands-on manner, and this is little advanced where we'll be utilizing various tools and technologies. You might not know on the day one about all those technologies. I'll do my best to simplify it so that you understand it, how it is working together. Okay, so we'll be seeing as how to create a GitHub Actions file, and we'll create a Docker container on a machine learning project. We'll create a Kubernetes configuration file. We'll deploy the machine learning application that we have created on the Google Kubernetes engine. And we will be implementing and testing this CI/CD pipeline in a hands-on manner, where we will do some modification on source code. We will commit those changes into our repository, and we would go ahead and validate it whether it is deployed, the latest version has been deployed into my server or not. Okay, that's the kind of validation that we are going to perform right now. It's a basic CI/CD pipeline which will be implementing it for the machine learning project. So let's go ahead and perform this activity, guys. Now, for the benefit of time, so what I have done is I've made use of the already created machine learning project. So if you have been following my work, so we have published a course on manifoldai-learning.in, which was about the machine learning deployment. So there is a YouTube playlist around this as well. So here, under this course, we have actually created the deployment using the Flask application. So there's an end-to-end deployment v1 file that I have attached over here in this section. So I'll be using the same code file which we have implemented last time, and we'll be deploying that application into the Google Kubernetes and we'll create the GitHub action and perform the automation, guys. Okay, I'll be making use of this file. So if I bring up that file, so you'll be able to understand what is happening right here. So here, let's take a look into the notebook that is created. So this is basically classification.ipynb file. So this is a notebook which has the experimentation part and creation of the model part. So to give you an idea, so to get started here, I'm loading my data set. Okay, I'm loading my data set. And once I load this data set, which is an iris data set, a very simple example that I'm using right now. If you look into the shape, there is 150 rows and 4 columns, a simple iris data. So we've got 4 features, right? So those 4 features are represented in my data. And this is basically a multi-class classification. I've got 3 classes, right? 0, 1, 2. So it's a multi-class classification. Okay, now the target names are setosa, versicolor, and virginica. So basically, given the sepal width, petal width, given these features, I want to classify each row to one of the classes, that is whether it is setosa or versicolor, virginica. So I want to perform this basic classification. Now I've got a question for you. So when I say classification, so to what kind of machine learning does it come under? So what do you think, guys? So under what type we say this classification is under? Okay, that's correct, Akshay, Deepak, Sridhar, Lakshmi. Okay, so what about others? What do you think? What kind of task that I'm performing right now? Like what type of machine learning it is? Sridhar, Samiksha. Okay, I see some more responses too here. Dheeraj. Perfect, guys. Yes, as most of you have mentioned, it is a supervised learning, which is nothing but the classification task. So the type of machine learning that I'm implementing is the supervised machine learning. So I hope we are all good right now with what we are doing. So it's a supervised machine learning and it's a basic classification. So since it's a classification, I have to use the model which is suited for this classification task. So for the demonstration purpose, here I'm taking a very simple approach, which is nothing but my decision tree model. So using this decision tree model, we would go ahead and find the patterns in the data set. So I'm importing this decision tree classifier. Then I'm also importing the standard scaler, the train test split function. So this would help me to split the data, and standard scaler will help me to apply the normalization on the given data set. Okay, next here I'm splitting my data set into 2 parts. One is training set and the test set. So I'm just splitting in the ratio of 80-20, which is a common activity that we do whenever we are applying any machine learning. Now once I split the data, I'm going to apply the standard scaler on my training data set. Now remember closely, when I'm applying the standard scaler on my training data set, it is fit transform on the training data set. So to give you the idea as what happens when I apply this transformation. So basically, we will be going ahead and finding the value of mean and standard deviation for each and every column in my data set. And once I get the mean and standard deviation on my each and every column in my data set, I would I would go ahead and change the values of each and every row such that I'll deduct the mean of that column and I'll divide it by the standard deviation. Now by doing like this, I'll be transforming the data. Okay, I'll be going ahead and transforming the data. Now I've got a question for you guys. When I apply such standard scaler on this given data set, what do you think is the range of values that I would get if I transform my column, each column? So what would be the new range of values that I would get? Okay, let's talk about one thing. Okay, let's talk about mean. What would be the mean value if I perform such transformation, and what would be the standard deviation value on that entire column after I perform this transformation? So I know that most of you are responding. Okay, Lakshmi's, Samjeev. Okay, so So Satyam, perfect guys. So as most of you have responded, yes, the mean will be 0 and standard deviation is equal to 1. So that's how the standard scaler will have the effect on my given data set when I apply it on the given data. Okay, so I hope it's clear now. So we are going to apply the standard scaler and we are able to transform this data such that we'll have the mean as 0 and standard deviation as 1. So I'm applying this on my training data and using the mean and standard deviation of my training data, I'm performing the transformation on the test data. Okay, so that is happening here in the step, and then on this transform data we would go ahead and apply the fit. Okay, we can go ahead and apply the fit. It looks like, let me do one thing guys. Okay, so I think in this code maybe I'm directly applying my training data. Okay, so you can just go ahead and run it this way as well, where you would perform the transformation, and after you perform the transformation you can go ahead and transform the data. Okay, I'm not going to modify it, so you can take it as an hands-on. So in this case I think I'm just for the demonstration I'm directly performing the fit over here in this code. Okay, once that is done, so once that training has been performed, okay, so what we are doing right now is, okay, we are going to perform the fit on this data set, and after that the important thing is we are going ahead and taking the dump. Okay, we are going ahead and taking the dump of the files that I have got. The two important files are final model.joblib file and standard scalar.joblib file. So they are nothing but I'm externalizing these files. So let me do one thing. Since it's used, let me just re-execute this code that I have got. I'll just launch the Anaconda Navigator and I'll execute this code so that I can show you right away as how it works. So what I'll do is, it's a good activity as well. So here, yeah. So what I'll do is I'll just quickly fix this. So instead of performing the train with xtrain and xtest, we'll make use of it in this way. Okay. So I'll just say run all so that the everything will be executed. So what I have done is, after executing everything, if I bring up my folder structure, so we can see that the two new files have been created. One is a standard scalar and the other one is a final model. Okay, so I have actually saved these two files with me. So these two files I have actually exported. The reason because here, whatever the model that I have created just now, it is basically present in my notebook. If I want to use it outside this notebook, I have to save it somewhere so that I can share it as a file. And for that specific reason, I went ahead and saved that file. In order to save that model as a file, I've made use of a library that's called as joblib library. And using this joblib library, I have saved it and I've made use of the function of dump. And using this function of dump, I'm able to go ahead and save it as a file, that is final underscore model dot joblib. Okay, I'm able to save it as a file. So I'm saving my model as well as I'm saving my the standard scalar which I've saved earlier. Okay, so that's the main intuition of saving these two files. Now, if I'm building any machine learning application, at that time I can go ahead and use this file itself. I can use this file and load the model. So I can use this file and load the model and I can apply the prediction on top of it. So that's how the approach is being followed. Okay, so to go ahead and perform this activity, so what we have created already is we have created a Flask application. If I bring up the code for my Flask application, here there's a file that's called as app.py. This is basically my Flask application file. So Flask is a library that we use it to create a front end using Python programming language. Now in this case, so like I have already implemented this Flask and this Flask based application. And if you just look into the code right here, I'm importing the Flask library, NumPy library, Pandas library. I'm also importing the joblib library. And along with that, here I'm going to load that model that I have saved earlier from this file structure. So I'm saying it as joblib.load. I'm loading the model from this file, and then I'm also loading my standard scaler. Okay, I'm also loading the standard scaler. Now, when someone launches the Flask application, by default, I'm routing it to the index that is slash. Now, at this place, I have created an HTML file. This will be rendered for me when someone goes ahead and launches my Flask application. So the code of this index.html is present inside the folder of templates, and under this there's an index.html where there's a file that is present, and it's a HTML file, and I can just show you to you as well. So this is basically an HTML file which is index.html, and using this front end, which is my web, which is the index.html, this will be open when someone launches this Flask application. Okay, so that's what this index.html says, because I'm making use of the function that is called as render template. So using this render template function, so we would be going ahead and opening this index.html. Okay, so that's what is going to happen. Now, if someone goes ahead and launches the slash predict, so these are nothing but the the path guys. Okay, so when we say slash, it is basically the home page. So if you go to the flipkart.com, when you say flipkart.com, it is indirectly saying that this is the home page, flipkart.com slash. It is nothing but it's a index page. Okay, now if you want to go inside any specific page, what you will do is you'll say flipkart.com slash, and you will mention the page name, right? Let's say clothing. So that's what I'm saying. If someone goes to the slash predict, and the method that I'm using is post. So when we are working, so we generally have multiple methods that are supported, like one is get and the other one is post and so on. So in this case, so I'm implementing the post. Okay, which means I can send in the request as a post request. I can send in the post request and I can get the response. So I'm using the method as post, and after I get this method as post, okay, so what I'm going to do is whatever the input that I'm getting in my front end, I'm just processing that input, performing the transformation, and generating the prediction. And if the prediction is 0, I'm mentioning it as setosa. If the prediction is 1, I'm mentioning it as versicolor. If the prediction is else, I'm mentioning it as virginica. And this is going to render the predict.html. And if someone tries to run this Python script, so he or she is going to get the front end right away. He doesn't have to mention anything, he or she. So everything is mentioned over here, this underscore underscore name underscore underscore. So this is a special value that we would mention, which will ensure that what exactly it has to run when someone is trying to execute. Okay, this is a very high level idea about how this application would look like. Now for the demonstration purpose, what I'll do is I'll just run this Python Flask application. So I'll just say Python, the file name that I've got is app.py. So if I press the enter key, so it says, okay, it is running on my server, and this is the host of 5000. Under the host of 5000, it says my application is running. I can go over here and I can go to the local host of 5000. See, it says ML model deployment demo v1. So my application has been deployed in my local system and I'm able to view it. And there is an instruction over here. What it says is we have to enter the inputs for the machine learning model, which is separated by spaces. That is how I have designed this application. So the reason that like that I have mentioned, because that's how I have implemented in the backend, guys. Okay, so for the demonstration purpose, I'll mention four values like 5, let's say 23, some 4 and 1. Okay, so they are just random four values that I'm mentioning. Now what happens is if the user mentions four values, so each value is being mapped to my individual feature in my backend. Okay, it is being mapped to the individual feature in the backend, and when you click on the submit button, so it is going to process my individual input with the help of standard scaler, and it is generating the response page. Okay, it is generating the response page. So here it says my class is versicolor. So my model has been deployed in my local system. Okay, this model has been deployed on the local system. So that's a good thing. So we have been able to perform the deployment. Now, the next thing that I want to do is, okay, so I want to go ahead and ensure that this model that I have created, it can be run on any system when someone is trying to execute. Now, the question is, how do I do that? How can I ensure that this model that I have created will run on any system? Well, I can only ensure that my model which I've built right now can be run on any system by ensuring that the dependencies are maintained, which means whatever the version that I have used in my local system, I have to ensure that the same version is present on the other system as well. Now, this brings to the topic that we have discussed in the earlier parts of our MLOps journey. So, if you remember on our previous live sessions that we have conducted, so I talked about packaging the machine learning model. So, we've talked about the packaging the machine learning model where we have understood about how the importance of packaging and the requirements of the same. So because of that reason, so obviously to ensure the repeatability of the model, we'll have to create and maintain the consistencies as well. We'll have to create the requirements file which will capture the same elements that I've got in my local system. See, the important thing that I've used in order to build my Flask application is one is Flask library and the other one is scikit-learn, and apart from that I think there has been a usage of pandas and the numpy library. So if I want to replicate this code in any server, that server should also have the same versions of the uh, libraries that I'm working with, because if there is any mismatch in the library, then we are unable to have it replicated. So for that reason, I'll just start by getting the version of the various application that I've got. So one is Flask. So it is 2.2.2. So what I'll do is I'll maintain a text file that is requirements.txt file. And over there, I would go ahead and mention those version. Flask is 2.2.2. That's the Flask that I've used. And then let's check the scikit-learn. So it is 1.2.2. Okay, so that's the version that I have to maintain. Yes, it looks like I'm using the same. Next, NumPy 1.24.3, joblib, so 1.2.0. So I would just note down all the version and I'll ensure that same versions will be captured in my requirements.txt file. Okay, I've captured all these files over here. Okay, I've captured all these versions over here. Okay, now once I've captured all these versions, what would be the next step? Well, once I've captured these versions, the next step that I'm going to do is I'm going to create a Docker file where I would mention the steps that has to be performed in a sequence so that this model can be deployed. So there's a Docker file that's already created. So if you look into it, it's a very simple Docker file that has been created, which captures the basic details and replicates the steps that we are going to perform. So first thing is I'm going to get a base image. The base image is Python 3.10. That's the base image that I would consider. And I'm going to copy all the files in my current directory. That is all the files that you see right here. I'm going to copy all these files. Okay. I'll copy all these files and I'll go ahead and copy it to my container. And I'm going to run the command of pip install requirements.txt. That means I'm going to install all these libraries in that virtual environment. Now, once I've done the preparation, then I'm mentioning what is my entry point. My entry point is Python, and the command that I want to run is app.py. I'm exposing the port of 5000 because that's the port in which my application will be running. So I've created this Docker file. Now, once I've created this Docker file, I can go ahead and run the command. I'll just go ahead and mention this commands to over here. So I'll just say, first thing that I'm going to do is I would go ahead and perform the activity of build. So I'll say docker build -t, and I'll have to mention my, let's say, a repository name. So just for the demonstration purpose, I'll use my repository which I have in my Docker hub. So I'll say docker build -t, and I'll mention as flask demo latest. Okay, and apart from specifying the Docker repository and the version, I'll have to mention as where my Docker file is present. I'll mention as dot. Dot means that's the directory. In my current directory, I have this Docker file present. So I'll mention this command in my command line interface. I'll just exit what I was running earlier. Okay. Now here I'm inside the folder where this Docker file is present. So I'll just run this command. So this will perform the Docker build. Okay, so this has performed the Docker build. Now, once the build has been performed, so let's go ahead and test if it is working or not. So in order to test, I'll say docker run -p. So I'll be exposing my port of 5000 to 5000, and the image that I'm going to run is the image that I have built. Okay, it looks like there is an issue. It says from work, so cannot import URL code. I think this seems to be one of the issue with Flask that we are working. So let me just go ahead and resolve it. Okay, so what the solution is, I think I'll have to add this as well in my requirements.txt file. Okay, let me again perform the build and we'll run the same. So to confirm, what I'm doing right now is I'm just trying to replicate it in a new virtual environment, which is a Docker environment where I'm using the Python as a base image. And in that image, I'm trying to execute all the command and see if it is working. Now I'm launching the container from that image to see if it would work or not. In my case, once I've fixed that code, it is working. If I go to the local host of 5000, I should be able to launch it again. See, I'm now able to launch it, and this time I'm able to launch my application from the Docker container that I have created. Okay, so that is what I have done till now. So to give you a quick recap, so what I've done is I've created a Docker file using the Python Flask application, and then I have built that Docker container image. And after that, I went ahead and run that in my local system to see if it is working or not. I'll take a pause here, guys. So any question, team? Do you guys have any questions or any queries? So please let me know. Do you guys have any questions or any queries? Okay, I see a question. Okay, it's not a question. It's basically kind of a query, sir. I've joined from YouTube. Okay, but there's a lag. Okay, let me do one thing, guys. So folks, in case if you're having any lag, so what I'll do is I'll just mention the link, meeting link. In case if you're having a lag, whether it is through the other platforms, you can just use this link and join it into the meetings, and you can also ask questions as well once you have joined at a later point. Okay, any other questions, team? Any questions? Were you able to follow? Okay, so there's a question from Satyam. Satyam saying that why are we saving the standard scalar object? That's a good question, Satyam. So the reason that I want to save the standard scalar object, because if I don't save it, think of it in this way. Let's say my values are 10 and 20 and 30 and 40. So during my training data, let's say this is my training data. Now on this training data, I have applied the standard scalar, and let's say once I've applied the standard scalar, the feature values will become 0.1, 0.2, 0.3 and 0.4. I'm just giving a hypothetical example. Okay, this is my transform data. Now when I'm performing the fit, I'm using this X as my X train, which is in the scale. Now, while performing the prediction, when my model is deployed, I'm getting the new data. Now, let's say when I'm getting the new data values as 30, 40, 50, and 60, if I directly use this value as it is to generate the prediction, it would be wrong, because during the process of training, I have made use of my standard scalar to transform the data, and on that transformation, I have performed the training. In the same way, I have to perform the standard scalar first, and I cannot randomly choose any standard scalar. I have to choose a standard scalar which I have prepared during my training, and then I have to perform the prediction. And because of that reason, I have saved this standard scalar object as well in a separate file, and I have used this file during the prediction. Okay, is it clear, Satyam? Okay, what about others? Any other questions, team? Okay, thank you, Satyam. Okay, perfect, guys. Okay, any other questions, team? Great. Thank you so much, everyone, for your confirmation. So, with your confirmation, I think that I've got, so you're able to get a high level details. I can understand if you're new to the Docker, don't worry about it. Just look into the high level flow. Obviously, as you progress, like as you progress in your MLOps journey, when you explore more, so you can directly implement it on yourself as well. Okay, so we have got the Docker file present, and we have created this Docker file, and we are able to run that Docker file. Perfect. Now this is looking good. Now it is working in my local system. Now the next thing that I want to do is I want to implement it on a server. So let's think about the architecture. What are we trying to do right now? So if I want to describe what we are trying to do right now is currently, okay, we have we are going to host the code in the github.com. Okay, so this is where we will hosting the code. That means the code that I've got in my local system, so I'll be maintaining it as a git repository, and I'll be pushing that code into the github.com. So I have my local repo, which is basically my folder structure, like my local folder. I'm going to host it on the github.com. Okay, now once I perform this activity of hosting my local repository to the github.com, then I will use the code which is present in my github.com. I'm going to like whatever the code that I've got. So using that code, I would go ahead and perform the build. Okay, I'll build the Docker image, and I'm going to push the Docker image. Okay, I'm going to push that Docker image to the, let's say in my example, Google artifact registry. Okay, I'm going to push that Docker image to the Google artifact registry. So the question that you might have is, what is this artifact registry, or what is the meaning of it? So think of it as a place to save the Docker image. So just like you have the GitHub to save the files, right? Your code file, think of it as artifact registry as a place where I will be saving my Docker image. Now, using the file, like using this Docker image that I have pushed, okay, what I'm going to do is I would go ahead. So I would go ahead and use this file and deploy it in Google Kubernetes engine. Now there's a reason that I've selected this Kubernetes engine. See, the reason that I've selected this Kubernetes engine, because if you look into this demo, you can replicate it on any cloud environment, because Kubernetes, the code that I'll be using, it will be the same irrespective of where or which managed Kubernetes service that you're using. You can use it on AWS, you can use it on Azure, you can use it on your custom infrastructure. So Kubernetes is a default way in which we are going to deploy our cloud applications. Okay, so as a result of this, I'll be showing you the code in the demonstration. I'll be showing you the demo on Google Kubernetes Engine, which you can easily implement it on your own environment so that you'll have a complete control of your environment and where you are deploying your machine learning application, guys. That's one of the main reason that I've chosen Kubernetes as an option of deployment. Now, apart from this Kubernetes, there are other various options as well. So like you can make use of Azure App Service if you're in Azure, or there are other application services as well in the various cloud platforms. So, but that would be specific to the vendor platform. So since the main intention is not to be specific to the vendor platform, so that's one of the major factors that I have considered while choosing this Google Kubernetes engine. Okay, now to implement this architecture, there are some system setups or the steps that we have to follow. So first and foremost, we need to have our code into our GitHub repository. So we need to have this code present in our GitHub repository. So in our case, so what I have done right now is I have hosted on my GitHub repository. So the code that I've got is Flask Dev GKE. That's the repository where I have hosted the code. So what I will do right now is I would push my code to this GitHub repository. So this completes the first part, that is hosting the code on the github.com. So I have made some changes right on the code which I've got. There are some changes that I've performed. Let me commit those changes and I'll push it to the GitHub repository. So I'll say git add dot and git commit -m, and I would go ahead and like I'll just say it as updated code. Okay, that's the comment that I would mention. Now this has committed to my local repository. Now I would push these changes to my remote repository, which is hosted on github.com. So git push origin me. Okay, so this will push the changes. This would ensure that my code changes that I have got, the code that I've got in my local system is going to match the code that I have got on this on the github.com. Okay, so let me refresh the page. See, there is a updated code. That's the latest commit, and the commit has been performed just now. And there's a question right here. Anurupa says that how do you come to know that the Docker file to model deployment interface? That's a good question, Anurupa. So what we have done is here in the Docker file, the command that I have used is dot and dot. So if I want to specifically say, or if I mention what is happening, so think of it in this way. So when I'm executing this Docker file, so what happens is in the back end, it will create a kind of an environment, virtual environment for us. And this virtual environment has Python 3.10. And this box over here, this represents my current folder. In my current folder, I have got various files, like I have my app file, classification, deploy, Docker file, model file, requirements. I have all the files. So when I say copy dot dot, what it means is it will copy all the files in my current working directory to the virtual environment. So it will copy whatever the files that I've got, it will copy it over here inside this virtual environment. So this Docker file will have all the files that I've got in my current working directory so that it can execute those commands. Okay, so this has got all the file now. Now, once it has got all the file, what it has to be done over here in this environment, first thing is use the requirements.txt file. So first it was not there, but I have copied it in the previous step. So use this requirements.txt file and run this command pip install requirements.txt, so that first in this new environment, it will install the same version that I have got in my local system. Okay, then I'm saying that run the same command. See, in my case, I also ran as python app.py, right? I'm just executing the same using these two commands like entry point and cmd. So that's how I'm actually integrating that's how this Docker file is ensuring that the files that I've got in my working directory is also present in this environment. Okay, so is it clear, Anurupa? Okay, thank you, Anurupa. Perfect. Okay, so what we did is currently, as of now, we had the code in a local repository, and we made use of the command of git push to push our code changes to our github.com. So I had already created the repository in my GitHub account. We have seen already in the last session how to create a GitHub repository in the last session. So I've just added the same and I've pushed the code changes. Now the expectation is I want to build the Docker image. See, to build the Docker image, I've already mentioned the code that you have to use. So the code is Docker build and you would mention it. But there's a special requirement that I have also mentioned, right? So I have to build it such a way that I should be able to push it to my Google Artifact Registry, which means you would require the Google Cloud account. So in my case, so I have already created, I have a Google Cloud account. So I would just go to the site console.cloud.google.com. Now, if you're someone who do not have the Google Cloud account, you can just go ahead and do a quick Google search. So if you can get the Google credits for free, like Google Cloud account, if you do a quick search, okay, so or the Google Cloud platform, so you can go ahead and perform the sign up and you'll be getting the $300 for free. Like you'll get the $300 credit for free, and you can use this to practice around and to work in this Google Cloud environment. Okay, so that's what you can do it, guys. So here in my case, so I went ahead and I have my cloud account present. So I have to create the repository for this Google Artifact Registry. So what I'll do is by logging into my Google Cloud platform, I'll search for the Artifact Registry. So there's a service that's called as Artifact Registry. And over here, I would create the Artifact Registry for me. Okay, in this case, there is a flash dev and my demo. So what I'll do is I would go, since I'm going to show you the demonstration, I'll just delete the ones that I've got in my system just to avoid the confusion. Okay, so what I'll do is I will say create a repository and mention your required name. Like I'll just say Flask CI/CD. That's the name that I'm going to mention. This is a repository. The format, choose it as Docker, and region I'll select as, let's say, US Central 1. That's the region that I'm going to select. And I would say delete artifact if I delete it, and I'll say create. So this is going to create the artifact registry in my Google Cloud account. Now, in order to be able to communicate from my local system to the artifact container registry or my Google Cloud, so we need to install the Google Cloud CLI. So you can just say Google Cloud CLI. So you can search for Google Cloud CLI install. So you can quickly go ahead and install this Google Cloud command line interface. You can follow the steps here. I'll mention the instruction. So this is the link that you would use it to install the CLI. And once that is done, so just follow the instruction that is present right here so that you can work with the same. Okay. Now, once you have done the installation, in my case, I have already done that. Okay. So once you have completed that installation step, so you can go ahead and validate it by running the command of gcloud -- version. By running the command of gcloud -- version. So this would go ahead and validate it whether you have the Google Cloud has been installed or not. That's an important, guys. Okay, this is one of the prerequisite steps which you need to do in your system to interact from your local system to the Google Cloud server. Okay, so now once that is done, so another easiest thing that I would recommend is, okay, so another easiest thing that I would recommend is, so you can just, I think, go gcloud login. So you can simply say gcloud auth login. That's a common command that you would use it. Gcloud auth login. So just run this command, and once you run this, so you will be able to authenticate your local system CLI with the Google Cloud account. So these are the two steps that I would recommend that you do it. So once that is done, so you have your Google Cloud interface present with you and it is connected to your Google Cloud servers, then you can interact with the artifact registry that you have created. So once you create this artifact registry, if you click on this and click on the option which says setup instruction, it will show you how you need to set up. It says gcloud auth and you have to execute this command over here. So in my case, I have already done this, but I'll show you in front of you as well. So you just have to run that command and press the enter key. In my case, there's already present. So it says I don't have to worry about it. But if it's not present, it is going to ensure that you will be authenticated for the artifact registry in that region of US Central 1. Okay, this is a prerequisite, guys. Okay, now once this is done, the next step that you need to perform is you have to push the code, whatever the code that you have got in your local system, you have to push that code to this to this registry that you have got. So you can actually do it right away, or what you can do is you can do it at a later point. So just to ensure that you have all the things set up, so the way in which that you would push the code is, so I'll just take the help of the previous implementation that I have done so that I'll be able to share you the code. So you'll just say docker build and you will tag it. And when you're tagging it, you will be tagging it in a specific manner. So first is you will mention your region. Okay, I think there is already a code help. There's something that I've used already here. I'll show you this. So this is how you need to perform the tagging. So this is basically the zone in your Google account, followed by docker pkg dev, okay, followed by your project ID, followed by your repository name, followed by the image name that you want to give and the image tag. Okay, this is the format in which you have to send the commands. So I'll mention the equivalent command in my case. Okay, in my case, the equivalent command will be my zone is basically US Central hyphen US Central 1. US hyphen Central 1. You can actually get to know about its region by looking at the location US hyphen Central 1. Okay, that's how you can actually get the one, and then followed by the project ID. So you can get the project ID by clicking any resource. You can just go inside this resource, and I think somewhere it will be mentioned your project ID, or you can also get it from the other pages as well. See, if you look into this, it says Civic Rhythm 404204, right? So this is basically my project ID. You can also get it by expanding your project ID that you have created. So this is my project ID. So I'll mention my project ID followed by the repository name. So repository name is basically the artifact repository that I've created, that is Flask CI/CD. Okay, I can just copy it. So I think the best part was when I copied it, it copied completely. So you can come over here in this page and click on copy. It will copy the entire structure itself. And once you mention it, okay, I'll just replace everything since it was copied. Okay, so once that is done, we can go ahead and mention the image. So for this demonstration, I'll say Flask demo. And for the image tag, I'll just mention it as latest or V1. I'll just mention it as V1. So what it means is there's no change in the code that I have done. Only the changes as how I'm naming my Docker container image. That's what this command says. Docker build -t is a command that I'm going to use it to tag my Docker image. Okay, to tag my Docker image in a specific format. So this is a requirement from the Google artifact registry. The same is true even when you're working with Azure as well. So if you're working with Azure, you will have something called as azure.acr or something. Or if you're working with GitHub Container Registry, so it will have something called as GCR. So this is a common activity, guys. Okay, this is not special one. I'm just mentioning it as per the requirement of this Google Artifact Registry. So I'll just perform the steps over here by docker build -t. This will just perform the tagging. So this will again perform the build activity with the new tag that I have just created. Okay, so once I have performed this activity of build, okay, so what I'll do is this time I'll run the command of docker push, and I would go ahead and mention this complete tag that I've mentioned earlier. US Central 1, so I'll just say docker push and mention this. So now when I press the enter key, the Docker image that I have just performed the build, it will be pushed to my artifact registry. Currently it is in the process of pushing. Let's wait. Okay, Shruti, okay, there is a Teja says about CI/CD. Can I listen to this? Okay, no worries, Shruti. Yeah, I can share some additional resources as well. Okay, let's wait, folks. Currently it is in the process of executing. Hey guys, as I mentioned earlier, in case if you want to speak, yeah, you can join the meeting link that I have pasted in the chat, the Zoho meeting link. You can join and I can enable your mic as well. Okay. In case if you want to interact with me directly. So there are a lot of questions around I'm unable to ask the question. Yeah, you can do it in that way. Just join that meeting session and let me know in the chat window. I can unmute you in case if you have got any specific questions on the topics that we are discussing. Okay, so here we can see that the push has been completed. Now what I'll do is I'll refresh the page, which is my artifact registry that we had created. If I refresh this page, we should be able to see that there's a new Flash demo, which is a Docker container image has been pushed. And if I click on this, the tag that I have added was v1, and we should be able to see that tag. So what we have actually done is from our standpoint, so we have built the Docker image and we have pushed it to the Docker container. It's for this Google Artifact Registry. Okay, we have pushed this image to the Google Artifact Registry. So this completes that. Okay, whatever that we have created, so it is working in line and we were able to push it. Now what we are going to do right now is I'll make use of an automation which we call it as GitHub action. Using the GitHub action, I would go ahead and automate everything. Like if I update my source code, I will automate such that that source code on top of that, I'll perform the build as a Docker image and I would push that build Docker image into my Google Artifact registry. So that's what I'll be implementing the automation right now. Okay, that's what we would be going ahead and implementing this automation. So let's do one thing, folks. Let's take a short break of 10 minutes. Once we are back from break, we'll implement this automation, and I'll also talk about the Kubernetes file that I've created so that we can test these in action. So let's meet after 10 minutes, guys. In the meantime, if you have got any question, let me know in the chat window. I'll try to respond it over the text or else we'll answer it once we are back from the break. Okay, let's meet after 10 minutes. Okay, guys, I hope everyone is back. So let's continue, everyone. So before we went in for a break, so what we did was we have had written our code in a local repository. We have hosted on the github.com. We have built the Docker image and we have pushed our code to the Google Artifact registry. I mean, that's what we did in our learning journey. Now we will introduce the automation. To introduce the automation, I'll make use of GitHub action. So this is the official documentation page of the GitHub action. I'll tell you what exactly is this GitHub action and we'll just show you the GitHub action file that I have created. But before I show you the file that I have already created, so let me just help you understand what is this GitHub action. So this GitHub action is a continuous integration and the continuous delivery platform. So what is continuous integration? It's a methodology where the multiple developers would go ahead and save those code changes, and continuous integration will ensure that the code changes are collated and we are able to access it without any issues at a very high level. Okay, so that's the continuous integration. And continuous delivery is nothing but it's basically once the updated code is pushed to the repository, we would go ahead and perform the deployment. Okay, so that is what the continuous integration and the continuous delivery is all about. So first, let's understand the basics as how do we write this GitHub Actions YAML file, and then I'll take you through the same. So there's a learner which says, can you show the YAML file? Definitely shoot. Yeah, before I do that, first let me just show you the basics. Just understand the basics. With that intuition, when you look into our implementation, it will be much clear to you. Is that okay? Okay, perfect. So let's proceed ahead, guys. So here, let's proceed ahead and let's understand. See, when you're working with the GitHub action, so GitHub Actions is basically the workflow. Okay, so like this workflow is nothing but the sequence of steps that will be triggered one after the another. So we can configure that sequence of steps that has to be performed when a certain event occurs. Like an example, when I perform the code changes to my repository, some workflow needs to be triggered. Now this workflow is defined with the help of the YAML file. Okay, the workflows are defined by the YAML file. So I'll define this workflow in the YAML file, and importantly, I'll have to place this YAML file inside a special folder that's called as .github/workflows in my current repository. Okay, I'll have to create a folder called .github, and inside that I have to create a subfolder called workflows, and there I have to define my YAML file. Okay, that's the meaning of this workflow. And each event is nothing but when I want to trigger the workflow. Let's say there is a pull request happen or there's a push request happen. So that's when I'll be defining the event. And a job will also have the job. Job is nothing but it is a set of steps that I have to execute it in a workflow. Okay, so if I want to show you with this understanding that you now had, if you look into our local repository, like the repository that I've created, there was a new folder that I had already created, that is .github. Inside that, there is a folder called workflows, and inside that, there is a YAML file. Okay, that is what we have just understood as how I would place it. I'll show you over here as well. There's a .github/workflows. If I go inside that folder, there is a gke.yaml file. Okay, so that is a GitHub Actions YAML file. That's where I'll have to keep it. Next, okay, how does the YAML file would look like? The YAML file would look like something like this. First, we'll have something called as name, run, and when we have to run this, on refers to as when this GitHub action needs to be triggered, and the jobs over here describes the steps. Okay, so here it's an optional. If I just go over here, name is basically the name of the workflow. Run is basically the name of the workflow that gets generated during the run. On is nothing but the trigger, when it has to be triggered, when this action needs to be triggered. And jobs over here describes the various steps. So here I can say runs on, where exactly it has to run. Here I'm saying this as it should be running those below steps on the Ubuntu run Linux run now. And then we will have to mention the individual steps. So the steps over here is nothing but what are the actions that I have to do. Okay, what are the action that I have to perform? So in our case, if I come back to our code right here, okay, so there's a name that I have mentioned that says as build and deploy to GKE. Then, okay, on, under this on. So when I have to trigger this, I'm saying this as when I push it on the branch of main. Okay, when I push something to the main branch, this GitHub action should be triggered. And under the env, here I have defined some environment variables. Environment variables are nothing but the parameters that I want to use it during the runtime. So here I'm getting some project ID, my GKE cluster. This is Google Kubernetes Engine cluster. The zone in which my Google Kubernetes cluster engine is present. The image, what is the image name? In our case, the image name is, let me change it right away with the information that we have got. So the image name is Flask CI/CD, Flask hyphen CI/CD. Okay, Flask hyphen CI/CD. Okay, that's my image name. Next, image tag. So what is the tag that I want to use? I'll just say it as v1 because that was the tag that I have pushed here, right? So I'm just going to use it as v1. If I want, I can use it as latest as well. For now, to keep it simple, I'll mention it as v1 so that you can use the same settings when you're executing it. Then the zone, the artifact registry zone, it is US Central 1, and the repository name. So here, in my case, the repository is Flask CI/CD. That's the repository name. Okay. Okay. Repository name is Flask CI/CD. I think, yeah, this should be my repository. Okay. The image name here, it should be Flask demo. Okay. So these are the things that we are aware of that we have just pushed earlier and have maintained it in my environment variables. For these, we'll talk about it. Like once I create it, we'll come over here. Now let's look into the setup. Under the jobs, first thing is I want to perform the setup, build, publish, and deploy. So first, I will check out the code. So to check out the code, I have defined the step as action/checkout v3. Then I'll have to perform the login using my Google Cloud credentials. Now, in order to perform the login from my GitHub to my Google Cloud, I need to get the login details. So in order to get the login details, so what you need to do is, so you need to create the Google Kubernetes engine. It would create a service account and you have to use that service account and configure it under the GitHub. So I'm just referring to the credentials that we are going to get from the from our from the JSON file, which I'll be saving it under the GitHub action settings. Then, after that, I'm going to do the same thing. Like I would go ahead and perform the login. After I perform the login, what I'm doing is on that cluster that we have created. So I'll perform the build by using the command of docker login, docker build, and then we will push that latest version of the image to my Google container registry. In my case, at least, I think that's the artifact registry. Okay, once that is done, I'm going to deploy it into my Kubernetes cluster using the command of kubectl apply -f deploy.yaml. Okay, that's what we are going to do right here. Okay, so let's go ahead and let's complete this file over here. There are some things that we need to fill in. One is the GKE project, which is nothing but my project ID, which I have to save it as a environment variables. And I also have to require the credentials file as well. So let's first do that. First, we'll create the Google Kubernetes Engine Kubernetes cluster, and from there we would populate it. So I'm going to launch the Google GKE. I'll search for GKE. So this will help me. Okay, Kubernetes. Yeah, I'll go to the Kubernetes clusters. Okay, now here in this page, there's already a cluster present. I can use the same cluster or I can create a new cluster. I'll show you how you can create it. I'll say create, and in this page, so you can mention the details. You can simply say autopilot cluster and click on create. That's enough. That's enough for you to quickly create your Kubernetes cluster. And once your cluster has been created, once your cluster has been created, you can interact with this Google Kubernetes cluster by selecting the option of actions and click on the button of connect. The reason that I'm not going to create a new one, because to create a new Kubernetes cluster, we'll have to wait around 5 to 10 minutes. So instead of wasting the time, I'm going to make use of the cluster which I have created earlier. You can copy this command of connect and then run it in your command line interface. So this would go ahead and fetch the cluster endpoint, and it will be added to our kubeconfig file. Okay, it will be added into this Kubernetes configuration file. So once it is added to this Kubernetes configuration file, so I can interact from my local system to this Kubernetes environment. Okay, that's how I can actually do it. So I have created my Kubernetes cluster. The name is autopilot cluster 1. So that's what you would mention it under the GKE cluster. And for the project ID, it expects us that we create it as a secrets. So before we do that, or to get those details of the secret, I can launch the IAM, that is the Identity and Access Management Service, and here select the service account. Once you click on the service account, select the project ID which you're working. In my case, this is a project. And here, select the option of action and click on the button which says as manage keys. And from this page, I would recommend you to create a new key. So you can click on this create new key, select the option of JSON and click on create. This will download the JSON file. Okay, this would go ahead and download this JSON file. And once you have this JSON file with you, so the next thing that comes is inside this GitHub repository settings. So you'll have to head over to your repository which you have hosted on github.com, select the settings, and under here there is something called as the actions. Not here. Under the secrets and variable, expand the secrets and variable under the security and click on this option of actions. And from here, you will have to create a new repository secret. We'll say it as new repository secret, and you will mention the repository secret name as GKE project and mention the secret value as your project ID. In your case, so mention the project ID. In my case, it is this, my project ID. Okay, ensure that you maintain it. Now once this is done, okay, so you have to click on this add secret. Okay, I'll show you because I have already created, it's not allowing me. So I can just mention that value and I can add that secret. Okay, now apart from that, there's also one more secret that you need to create, that is GK. The other secret is the service account key, GKE SA underscore key. You'll have to create a new repository secret, and for the value, whatever the JSON file that will be downloaded. So in my case, if I want to show you, this is a JSON file that got downloaded, guys. Okay, this is a JSON file that got downloaded. So I can use this JSON file. I have to open it and I'll have to paste that complete JSON file over here. So since it contains the sensitive data, I cannot open it in the live session. But yeah, if you download and open that JSON file, so you can just copy all the file content and paste it here. Okay, so these are the two secrets that you have to maintain under the settings of your repository. So it will be secure, and the reason this is recommended because no one can access it except the repository owner, that is you. So it is not recommended to store such credentials in a configuration file. So create it as a secret, repository secret, and that will be referred in this GitHub pipeline file. Okay, in my case, everything is set up. So we have done all these things right here. Okay, so this will complete the file that I've got, that is gke.yaml file. Okay, now what I have to do is, as I mentioned, I'll be making use of the Kubernetes. So I'll create a deployment.yaml file, which is my Kubernetes configuration file. And there's already a deployment file created, and you just have to mention your image. Okay, you just have to mention your image. So in our case, so if I want to get the details, I can quickly come over here Yeah, I'll launch my artifact registry. This is the repository. Under this repository, uh, I would go ahead and copy this path over here. I'll just replace it. That's all. I'll just replace it. And the image name over here is Flask demo, and the version is v1. Ensure you maintain these values. Okay, so what I'm doing is I'm making use of my Kubernetes configuration file, which I'm creating it as deployment, which will use the image that we have pushed into this artifact registry. Now, once this is done, now observe the magic, guys. Okay, now observe the magic. So what I'm going to do right now is I would go ahead and update my source code. Okay, I would go ahead and update this source code to my GitHub uh, repository, and you'll be able to see that this automatic CI/CD pipeline would kick in with the help of this GitHub action, and we can validate that once the deployment is complete, we should be able to launch our application in our Google Kubernetes engine. We can actually validate it. So what I can do is I'll say git add dot git commit -m. I'll say demo code. That's the command that I'm going to mention. And git push origin main. Now once I press the enter key, so this will perform the commit to my repository. Now observe something that I want to show you. If I come over here to my actions, okay, let me do one thing. Let me just come to my browser itself, this one repository itself. If you see, there is an orange dot over here. So the orange dot says that there is an action which has been already triggered. Now, if I go to my actions tab, there's an actions that has been triggered, and this action, which is my GitHub action, has been triggered just now. There were other actions. These were because of my previous testing that I was doing earlier. So automatically when I push the code into my repository, GitHub action has been triggered, and you can expand the individual steps. What is happening? First thing is it performed the authentication, and then it has performed the setup of my Docker. Then what the next step is, it is performing the build. Once the build is performed, it is performing the push to my artifact registry. Okay, once the push is performed, this would go ahead and perform the deployment as well. Okay, this would go ahead and perform the activity of deployment too. So when we say deployment, it will be deployed into my Google Kubernetes engine, that is for my Google Kubernetes cluster as a pod itself. Okay, now, okay, it looks like somewhere we've got an error. Let's see what is the step. Deployment flash GKE not found. Okay, let me do one thing. I think it's because there was a code over here which has triggered it. So I think there was a code over here which was trying to delete the deployment, and because of that it failed. I'll just remove this code and I'll perform the retrigger, guys. I think this had to be changed. Okay, so just for the example purpose, I'll just say git add dot git commit -m fix git push origin main. So let it trigger the new CI/CD action. So this will trigger a new CI/CD action. I'll come back, and you can see that with the new push, a new GitHub action has been triggered. Okay, now it says kubectl, it is running the deployment file. So it has completed the deployment. Now let's go ahead and validate it. Since my local system is connected to my Google Kubernetes engine, I'll say kubectl get pods. So we can see that it is in the creation state. Let's look into the service as well. From there, I can actually get the IP address. Okay, so it is still pending. Let's wait for the pods to be created as well as the services to be up. Okay, my container is running. Let's look into the service. Okay, it is still waiting. I think this is going to create a load balancer, guys. So that's the reason it's taking a while. Okay, we can see an external IP. Now I can go to this external IP and I can go to this port of 5000. Say I'm able to access my application. Even you can try it at your end as well. I'll show you. Say until that session is time, the session is active. You can also try accessing this URL, and you can also try working concurrently. So even if multiple users starts interacting with my application, since I've deployed on the Google Kubernetes engine, so I'll be able to like the user, every user can simply work, can interact with my servers. Okay, so that's the best part, guys. So go ahead and experiment it. So you can say 10, 20, 30 or some value, click on submit. So this should generate the prediction. Okay, that's how we can deploy our machine learning model using the Google Kubernetes engine. Now, what happens when there is any change in the machine learning model? So just to replicate this, what I'll do is I'll just come over here and I'll modify my index.html from v1 to v2, which says that there's a change that I have done on my application. Now, how do I take care of that? So there are various ways of doing it. So since I've made use of a very simple demonstration, I'll just add one more command, kubectl. I'll just add one more command right here, team. Okay. So what I'll do is I'll say kubectl delete deploy dot YAML. So this is the additional command that I will do, that I will add it for this demonstration purpose. You like the best way is create it as a Kubernetes secrets and use it. So since most of you will not be aware of it, I'm just making use of a simple approach of manual deletion. In the production use case, we'll be making use of this Kubernetes secrets. Like while doing the hands-on as well, like when you're executing this pipeline file, you can remove this first line and execute it. And for the further updates, just ensure you add this file, that is kubectl delete, and mention the deployment name of flask.tk. Okay, this will ensure that every time you update the code, the existing deployment will be deleted and a new deployment will be created. A very, I'll say, a raw approach for CI/CD. So obviously this is not the best one, but that's what you can think about from the beginner standpoint. Okay, as I mentioned, in the production use case, we'll not use it directly in this manner. So I'll just say v2 of my code and I'll push the latest version. So I'll push the latest version of the code, which is my version 2, and this should automatically trigger my GitHub action. We can quickly come back and check. See, it has triggered a new GitHub action, which is going to run my complete CI/CD pipeline, which is my workflow. So once it is done, so if we keep on refreshing it, so you should be able to see that new pod will be created in the backend with the latest version pointing to the version v2, which will be done automatically, guys. Okay, now let's wait for a few seconds. So I'll just say kubectl get pods just to check if it is created or not. Currently it is in container creation. Let's wait for a few seconds, guys. Okay, I can see my container is running. Now if I refresh the page, even you can try it at your end as well. So it should point to my version v2. So the code changes that I've done in my application, it has been validated and it has been pushed into my container registry, and it has been deployed on my Google Kubernetes cluster. So guys, as part of our webinar session, like this today workshop that we have got, we have seen the complete demonstration of how we can make use of GitHub, and making use of the GitHub pipelines, like GitHub actions, to implement CI/CD on the machine learning projects. Now, all these things have been implemented in a hands-on manner. Now, to get the sessions recording for your future learning purpose, so ensure that you refer to the site that I'm pinging again, bit.ly/manifoldailearning.in, where you get to where you can get the sessions recording as well as the source code that I have implemented as part of a learning journey. Okay, so let me share it in the other everywhere as well. So just refer to the code, just refer to this URL. So if you go to this URL, so just click on the button access now for free. So there's already a first sessions recording is present. So I think in 24 hours, the second day session will also get updated over here. Okay, guys. So do you have any questions or any queries from the learning journey that we have got today? It's time for Q&A. So please let me know. Yeah, before that, there's one more thing that I want to let you know, guys. So to help the learners, so if you have liked the session, so I request you to share it on your professional network so that the other learners can also benefit from this session. Now, if you're someone who wants to explore more from the MLOps side and do everything just like we have done in the learning journey and implement the CI/CD as well as CD pipeline in your machine learning projects, I would recommend you to check out the course on manifoldailearning.com, which has got more than 30 hours of learning content. This course has got more than 35 hours of learning videos on implementing the MLOps, where you will be implementing an end-to-end pipeline where you will start by packaging the machine learning model, working with Git and GitHub, how you would package the machine learning model, how to work with the YAML file, working with ML flow, Docker, how to work with Docker, how you would build the machine learning application using fast API, Streamlit, Flask, Linux operating system, Jenkins. How do you monitor the production environment? How do you work with DevOps concepts like Prometheus, Grafana, Docker Compose? It is filled with a lot of advanced techniques which we will be using it in the real-time projects. And also we talk about what we would be doing once we productionalize the machine learning model. So all these things is implemented in a step-by-step hands-on manner. So this is a special price that you would see on the site, which is valid only for today. I would recommend you to check out and make the most use of the course, guys. There's one more course. If you're someone who wants to implement it on AWS, there's another course which I've got an opportunity to create both of these courses with Manifold AI Learning. So do check out these courses. And I look forward to seeing you on the next webinar session, guys. And again, I want to thank each and every one of you for being so interactive in this session and asking some of the amazing questions in the session, guys. I look forward to seeing you on the next session where we'll come up with another topic. If you have got any specific topic that you want me to host, do let me know in the questions or the chat window. I can make a note of it so that the team can go ahead and like schedule it and in the upcoming sessions. So thank you again, everyone. Now, if you have got any questions, so please let me know. If you're clear and do not have any further questions, please confirm by typing as all good. And it was pleasure speaking with each and every one of you guys. Okay, I can see a lot of registrations that are coming up. Okay, Ranjita. Okay, Ranjita says, sir, I've enrolled for both. I'm looking forward. Okay, thank you, Ranjita. I can see Samiksha has enrolled, Prakash, Lakshmi, Dheeraj. Okay, thanks a lot, guys. Thank you so much, guys, for the others who have joined. But yeah, so folks, yeah, I request you to share with the other learners. They can get the most of the webinar that we have conducted. Thanks again, guys. So I'll see you next time. I'll be here for another minute for answering any other questions that you might have. And yeah, thanks, guys.
The recording has been stopped.
Okay, there's a question from Satyam. Is there any difference between MLOps and AIOps? So both are same, I would say, Satyam. So it depends on how or what kind of application where we have implemented the MLOps strategy. So uh,